Let's get started. Welcome everybody to the last computational social science seminar of the semester. And I'm happy to introduce Dr. Yuru Lin as our guest speaker today. Dr. Lin is an associate professor at the School of Computing and Information at the University of Pittsburgh, our neighbor. And she leads the Pitt Computational Social Dynamics Lab. Dr. Lin's interests are quite broad. She is a computer scientist by training, but she's also a computational social scientist who empirically studies large-scale social and political networks using surveys, social media, and cell phone data sets. She employs innovative data visualizations with both quantitative and qualitative methods to understand the dynamics that play out in large-scale online communities, such as misinformation, distrust, and how people react to sudden exogenous shocks, such as natural disasters or social and political events. Her innovative visualizations earned her the Most Influential Scholar Award honorable mention at the AI 2000 for outstanding and vibrant contributions to the field of visualization. So without further ado, I turn it over to Dr. Lin.
Thank you. All right, good afternoon, everyone. Thanks, Patrick, for the warm introduction. And thank you to have me here. It's a great pleasure to be here and honor to be the last in this semester. So I'm glad to present my recent study on this topic, the online-offline paradox, language literacy, and social inequality. So this is what you are going to hear from me today, a computational social scientist reflection on using computational measurement for studying complex social systems. So to illustrate this, I will use my study, the findings from my study of global literacy measure as an example. Okay, so a few words about who I am. As Patrick already introduced, I'm a computer scientist by training and later become a computational social scientist. In computational social science, as many of you know, the key is not to study computational system or to optimize computational efficiency. Instead, we ask how to get a valid, reliable, and scalable computational measurement to understand people's thinking and behavior, and to understand the social system where this thinking and behavior were situated. So my research is about designing and developing a data-driven analytical approach to study human social and political behavior as part of the social information ecosystem. And my research mainly concerned about how information is created and disseminated through this social technical system, and how such information exacerbates the polarization and biases in our social fabric. Okay, the work in my group mainly covers two areas. One is cyber social influence and integrity issues. So things like how misinformation, disinformation, conspiracy theories, and hate speech spread in cyberspace. Another area is ethical and accountable AI. So we want to understand how to build technology that can be conscientious about the social ramification that will emerge from this data science practice. For example, the content filtering or personalized recommendation may reinforce the stereotypical preferences or ideological preferences. So this will the system will induce biases into human society and then further exacerbate the polarization. So instead of being manipulated by the AI system, how could we leverage data and AI to mitigate the system-induced biases and stereotypes? So So now you know a bit about myself. Let's dive into today's topic. So, well, today the digital system, including social media, have been pervasive around the world. So even you don't use social media personally, they have significantly changed everyone's life, everyone's daily life, such as global connectivity and telecommuting, and it make information become more accessible than ever, and it create lots of business opportunity, not only for bigger company, but also for small business. Right? And then social media allow people to build community regardless of the geographical boundaries. And I want to highlight areas that I'm mostly concerned. The social media and digital platform have significantly impact civic engagement and democratic processes. For example, enhance public participation. So social media allows provide a available space for people, for citizens to engage in this political discussion. And social movements and grassroots campaign have used social media to increase people's awareness about certain social issues and garners support, social support, mobilize support. Voter education and outreach can be done digitally. So they have significantly contribute to the spread of political knowledge and increase diversity and political discourse. So social media can include more diverse voices, especially voices from people who are traditionally marginalized or belong to minority groups. So all these are positive changes. However, all this will not happen if people cannot connect to the online space. And the digital divide is the barrier to all these positive changes. So anyone want to make a guess what percentage of people in the world have the access to the internet?
15%.
15%? Okay. Any?
20%.
20?
60.
60? All right. 60 is the closest that we make lots of progress in the recent years. So even so, as of 2022, nearly 1/3 of the world population still offline. And millions of Americans, they do not have reliable internet access in their homes. And in the African region, only 40% use internet. So the digital divide has been considered as a gap between those who have internet access and reliable devices and those who don't. So the good news is the gap will soon become less of an issue. Why? If anyone are following this news, you may see this satellite just launched by Amazon a month ago. Hopefully you will play.
Amazon got its own Prime delivery on October 6th. United Launch Alliance sent a pair of Amazon satellites up to low Earth orbit on board an Atlas V 501 rocket. The mission was dubbed Protoflight. It was the first in a series of dozens for Amazon's so-called Project Kuiper, a satellite internet mega-constellation. It's the tech giant's answer to SpaceX's Starlink, as well as others who boast their own satellite internet constellations. Project Kuiper's Vice President of Production Operations, Stephen Mateer, said their goal is, quote, bridging the digital divide.
So you hear that, bridging the digital divide. So that's for these tech giants. The digital divide means a larger global market. That's why Meta, they have sent drones to develop countries 10 years ago. And Google sent balloons, and Elon Musk, SpaceX, they create they launched the Starlink network. And now Amazon, just a month ago, they launched 2 satellites. Their goal is to send over 3,000 satellites into the space to create this so-called communication constellation. So in a few years, we will have overwhelming connectivity. But we will still have digital divide because digital divide is not binary. So those satellites or whatever the tech company are building, they may address this basic accessibility, right? It means that the available access to the internet, but there's still affordability issue. It means that is the access affordable? How does the cost compare to people's essential goods? So without this affordability, people still cannot have the access to the internet. And moreover, we need to ask, is the access even relevant to the people? Does the connected community have the necessary skills to get connected? And is their content accessible in the local language and relevant to the people in the community? So without all this, the high-speed internet is irrelevant to those who currently don't have it or cannot benefit from it. So that's what motivates we start this project. So we want to measure the online literacy skills for the global population. So what's these literacy skills? So it has been understood. So the concept of literacy skills has been understood as a global metric to assess the competence. So how compatible the communities are. Traditionally, it has been measured as the ability to read and write. And broadly, it means the ability to communicate and interact with those around us. And it has been known as very important. So high literacy rate has been found to correlate it with almost everything, from better economic opportunity to better nutrition to higher environmental sustainability. And in this digital world, the concept of literacy has been expanding. So according to UNESCO, it's a means of identification, understanding, communication in this increasingly digital, text-mediated, information-rich, and fast-changing world. The problem is we don't currently have such global metric yet. So to give you an idea, let me show you how traditionally the literacy skill is measured.
Tim got off his bike. I will help you, Zach, he said.
So in this video, you can see the learner, the reader, the learner, this kid, try to recognize words in the reading context. So this is how traditionally literacy was measured, and it's hardly scalable. Right? So a more scalable way is through this so-called benchmark vocabulary size test, or VST. So it's a proxy for measuring literacy skill through understand what the size of vocabulary a reader has, because in order to comprehend the text, the reader has to know over 95% of the words. Okay, and the vocabulary is not all equal. They are lower level vocabulary, higher level vocabulary, and this having this higher level vocabulary is needed for reading a variety of texts, including newspaper. So how did that create this benchmark vocabulary? So typically, the expert we sample words from a large corpus, typically is from these British national corpus. And how they did is that they rank order those words based on how frequently they appear in the corpus. And then they rank them based from the highest frequency to the lowest frequency. And from every thousands of words, they sample 10 words to create this benchmark vocabulary. Use this vocabulary to understand people's vocabulary size. All right, so this project began when I was a visiting scholar at Meta. So our goal is to estimate the online literacy skills for the global population. And we focus on this language literacy. It means how a community can use language to communicate and interact with others using language. And the data we use is all public posts on Facebook across the world. And every day, Facebook has over 1 billion or more than billions of stories posted online. So there's a lot of data. So our goal is to create an efficient data-driven measure that tells the literacy level of any given online population just from the observed user-generated text. And there are two technical challenges. One is how do we distinguish the use of high-level vocabulary? And another is how do we measure online population's literacy skills in any given language? Because we know there are so many languages in the world. So is it possible to create a benchmark vocabulary that can be used across different languages? So this study has two parts. In the first part, I will talk about how we create this pure data-driven metric to assess the online literacy skills of a global population. And then in the second part, I will talk about how this metric can be used in various applications and also the quotients based on these metrics. Okay, so for measuring, this measuring approach is based on a very simple idea. So suppose we have all the words and we rank all these words based on how frequently they were used by the population using this language. We will see such a curve, right? So this is a word frequency curve. And at the head of this curve, the words first here is the most common words. So everyone uses them. There's no differentiability. When we move toward the tail of the curve, they are the most unusual words. Very few users use them. There's also no differentiability. So this leaves us this middle part, this so-called elbow range, right? So words first here, they are not as common as the most common words, but they are not as unusual that nobody uses them, right? So they are the secondary high frequency words, and we call them low words, standing for lower frequency, frequent words. So our algorithm is able to automatically detect these low words using this word frequency curve. So we develop an algorithm to detect these low words for any given language. We leverage fast text because fast text incorporate incorporate text in over 150 languages. And we use this language and Facebook public post to generate this word frequency curve. Then we can we develop an algorithm to detect this elbow range automatically from any word frequency curve. With this range, we were able to identify what words are these low words. And then we can measure for each individual, what's the relative rates, low rates in their text. And then we can aggregate these individuals' love rates into communities, countries, and the regions. So this shows how these look like in the empirical data. So this is in our empirical data, this is for English language tests. All right, so the love words we identify is rank between 5,000 and 9,000, which correspond to the traditional VST benchmark vocabulary that was captured in the British national corpus. And we then evaluate these measures. So using these automatically detected love words, we were able to create estimate literacy based on these love words. And we correlate this estimate literacy with the officially reported literacy for each of the country. And we get a pretty robust correlation. The only difference is in this traditional literacy measure, it's based on a literate, illiterate dichotomy. Whereas in our literacy measure, it's continuous. It's based on the relative rate of love in individuals' text in a population. So it provides a more fine-grained literacy scales. Okay, so what about other language? We also test different languages, and all of these languages we test, we get a pretty robust correlation from 0.63 in Spanish to 0.86 in Arabic. All right, so in this study, we use the most used 12 languages in the world, including English, French, Arabic to Malay and Italian. We use these 12 because it already covers 167 countries in the world whose official and dominant language are among these 12 languages. What about multilingual country? So we did a case study on multilingual country who use multiple languages in their nation. So we use India as a case study. So India has over 20 official languages, including the most popular Hindi, Bengali, Marathi. All right, so our result shows that we get a very similar result from the English, the most dominant language only, the metric created based on most dominant language, and the metric created by using multiple language. So the results are similar, but the official literacy data that can measure multiple languages literacy is either lacking or very outdated. So there's a huge challenge in using multiple languages for validation. So for validation purpose, we go with this most dominant language in this study. Okay, so in half of the study language, we found that the ranks of love words rank between 5,000 and 9,000. And there are other languages that have a wider or narrower ranges, such as Chinese, Russia, and Malay. So this happens when the language has larger or smaller vocabulary size. And our algorithm can automatically detect the love words regardless the characteristic of the language. Okay, a very interesting property in this study is that we found the majority of the language word frequency curve can be fitted with two log normal distribution. And this creates a very interesting insight into this word frequency, because the linguistic has been long debating this, which distribution is the right for word word frequency or word rank distribution. And many people believe it follows this famous Zipf's law distribution or so-called power law distribution. However, in a variety of linguistic data, people have found that log-normal distribution fit better than power law distribution, especially in the middle of the frequency spectrum. Some people also suggest truncated power law distribution, which can fit better than the pure power law distribution when the probability past certain threshold. And also, this truncated power law has a more sharply decline in the tail part, which fit better. So our observation about this log-normal, two log-normal model suggests that there are two similar but distinct multiplicative processes going on in the word use. And one of these is the words used by higher literacy group. So not only that we have a better mathematical fit, but we also can provide an interpretation about why the fit look like this. All right, so with the language-specific metric, we then create a calibrated model that calibrate all different languages, and we call this calibrated metric OLE, standing for Online Language Literacy Estimate. So O stands for online. All right, so with this OLE, then we can put all the countries with using different languages in the same scales. And we compare the estimate literacy with their official data, and the fit is pretty robust. All right, so now we have this OLE metric. I can now talk about the application. So one application, so there are various applications of using this OLE metric. And in this study, we focus on examining the online literacy disparity. Okay, let me get some water. So we use this OLE to measure the online gender gap in the literacy, in online literacy scale. So we break down OLE into women's group and the men's group for each country. So for each country, we can then put them into these scatter plots, the female OLE against male OLE. So if you see country above this line, means woman over man. If the country is below, means man over woman in terms of online language literacy skills. And the difference is captured as the female varying gap. All right, so now let's look at what happened in the online world. So typically, we would expect in many male-dominated society, men typically outperform women. But we found very interesting phenomena. In the online world, women tend to outperform men, especially in these economically advanced countries, right? So in these countries, we see they tend to have a high OLE in both women group and men group, right? And women tend to outperform men in their online language literacy skills, except for Italy, which we know is known as a male-dominated society. Okay, and we found a strong correlation between the online metric and offline metric. So we correlate OLE gender gap with offline gender parity metric, including the gap in offline literacy, women's civic participation. So that's the percentage of women participate in civic activities in the society. And also the GII, Gender Inequality Index. And we see significant correlation across all these. So the next important question is, what explain these variations? So we use the country's population characteristic to try to statistically explain the variation in the online OLE gender gap. So we include these theoretically interested factors, including women's civic participation, overall education, and internet penetration. This is percentage of people have the internet access in the country. Okay, so you can make a guess what kind of relationship these factors will have with the gender gap. Remember, this gender gap is female fairing gap. So if a woman has higher, then this will be more larger. Okay, so as we expected, women's civic participation and overall generation should reflect more a reduced gender gap. So they have a higher, they have a positive relationship with the OLE gender gap. However, we see internet penetration has a negative relationship with the OLE gender gap. So it turns out that a higher level of internet penetration exclude people from the lower socioeconomic status, exclude them from participating in the online world. So this lower internet penetration acts as an equalizer. So when people have internet penetration in those countries where they have lower internet penetration, they already pass a certain economic threshold. So when countries have a lower internet penetration, they ironically have a more reduced gender gap. And we also found a very interesting interaction between women's civic participation and the internet penetration. So let me plot this interaction in a two-dimensional heat map. So in this heat map, the X and Y represents internet penetration and women's civic participation, these two factors. And the colors indicates the female fairing gap. And you can see this interaction. The interaction can be clearly seen here. So when internet penetration becomes higher and higher, the female fairing gap is either high or low, depending on the woman's civic participation. So this implies that in countries where the women's civic participation is low, the women are not encouraged to participate in civic activities. The gap favoring men can still persist, even the country has higher internet penetration. So this is a very interesting insight. It means that internet penetration alone does not reflect in the online gender gap. All right, and another application is to measure the within country regional disparity. So we measure this as the entropy of OLE across different regions within a country. And we found a very similar non-trivial relationship among multiple inequalities. So in this case, it's the income inequality and educational inequality. And we found these inequalities and within country regional disparity. So in the interest of time, I'm going to skip this one, and we can discuss this offline if you are interested. All right, so to summarize this study, the main contribution is that we have a data-driven methodology of measuring online language literacy. It's scalable across languages and across countries. And this metric can be used to measure up-to-date global online literacy scales beyond the traditional literate-illiterate dichotomy. And we have a very interesting insight into this phenomena, which we call it inequality paradox. It represents the non-trivial link in gender inequality and regional disparity. Okay, so the social implication in this study is that technical advancement alone are not necessarily associated with more opportunity for disadvantaged groups, unless the disadvantaged groups can actively participate online. So the interaction between women's civic participation and the internet penetration is a good example for this. So there, okay.
I have a question about that conclusion, and it's related to slide 36, when you show higher internet penetration has potentially a higher gender gap, right? I'm wondering if that is a bad thing or if that is a good thing. Like, is it enabling lower socioeconomic status women to post more online, whereas they would not be able to post online if the internet penetration was lower?
When the internet penetration is lower, that means that more people cannot participate. So the reduced gap shown in the online world is just a slice of the iceberg.
I see.
Yeah. All right. So there's a structural insight into from this study, which is individuals are unequally disconnected from online environment. So when we measure a population using online data, we have to have this in mind. Okay. And I want to take a moment to discuss some of the lessons I learned from this study. So for a computational measurement like this, there are lots of strengths, but also have limitation at the same time. I want to use the computational measurement we developed in this study as an example to talk about the strengths and limitation. So this measurement clearly has several strengths. For example, enhanced understanding of language use. So it can be used in measuring how different language was used in social media. So it can help us understand the language diversity and language use. The main metric can inform policy making and also educational initiative for promoting the literacy, online literacy skills. And in fact, this work has been handed over to the Meta production team to discuss the collaboration, to collaborate with the international organization like UNESCO as part of their global metric for the world. And for researchers in communication, linguistics, and sociology, they can use this metric to study the language evolution, to study how to study the impact of collaboration on language use, and to study the role of social media on language change. Okay. So these are clear benefits, but there's also some challenges that can be associated with any kind of computational measurement. And for example, technical and resource constraint. So maintaining such measurement, global measurement, requires lots of technical resource. It's especially difficult when you consider the evolving nature of the language use in social media. So you have to keep updating this metric. And this can be overcome using our data-driven because all this can be automatically done. And language is very complex and multifaceted. So it's very challenging to capture, to have a comprehensive metric to capture the variability across different languages and across different social media. So this is also not a big issue as long as the data is available. All right, the other challenge, which is a bit more tricky, which is the privacy and ethical concerns. So we partly address this challenge by using the public post only, public post on Facebook. But there's a question about how representative the population can be captured using only the public posting. Okay, in the context of literacy, there's a risk of cultural homogenization. So because we want to create a global metric, so it unavoidably highlights the large community, the dominant language group, right? So this will lead to cultural homogenization. And the minority group can be further marginalized if the social system encourage or incentivize or force the community to conform with the global trend. Right? So another thing is we use language as a proxy for literacy. So this is just as almost every literacy measures in the past, like a traditional literacy measure. Most of the literacy measures use language as a proxy, but the concept of literacy is more complex, right? Actually, we need to measure how people understand and interpret the meaning using language. So this may not be fully captured by the language use. Another and final challenge is the potential for misuse and misinterpret the metric. For example, the population is so diverse and heterogeneous. So when we create a collective metric for the community, anything reflect in the change in the metric may not reflect things happen in the real world. So we have to be very cautious about these measures. So I want to so in this study, we largely overcome several challenges in this work, but there are also other emerging challenges associated with this data-driven measurement. So I want to cautious using a computational measure like this is a double-edged sword. And this is not only for this work, for almost any measure, computational or not. Lots of measure, especially global measure, will face these kind of challenges. So in the next part of this talk, I'm going to discuss how can we become more conscientious about the challenges, especially the last point that are rooted in data heterogeneity. All right, so in the previous work, I have shown you these paradoxical associations in the observational data, right? So in the next 10 minutes, I'm going to introduce the measurement tools for interpreting, identifying paradoxical association in the data-driven study. Okay, so many of you have heard this notorious Simpson paradox, right? Also known as spurious association. All right, it's a statistical phenomena that says a trend or relationship what can appear in aggregate data. And this trend or relationship can reverse or disappear when the data split into subgroup. For example, if you want to observe the relationship between cause and outcome, and then you see this downward trend, but if you split these into groups, the downward trend doesn't matter for any of the group. So when the Simpson's paradox occurs, the overall pattern can be deceptive or lead to incorrect conclusion. So for example, if you are a policy maker, a decision maker, and you want to see does a job training program help people increase their salary, and you plot the relationship between training and salary, and you see a downward trend, right? So the policymaker may then wonder, should we terminate the program since it's not helping, right? But this is actually harmful, because when you split it into groups, we see participating in the training tends to increase their salary for both groups. And the reason we see this overall downward trend is because Black people are more likely to participate in training, but they are also tend to have a lower salary increase. So the ethnicity seems to bring the confounding effect to these data. And that's a terrible news for data analysts, because how can we know if there's a confounding effect, right? So in this example, we want to examine the relationship between training and salary increase, right? So training represents a cost or treatment, and the salary is the outcome or effect. And the ethnicity acts as a confounder that influences both training, both treatment, and the outcome. Okay, so the research question here is, how can we identify confounding variables leading to such heterogeneous patterns? And how can we understand or explain the association clearly? And how can we make informed decisions even that the association is distorted or counterintuitive? All right, so the goal for this work is to help practitioner to handle spurious association in observational data. And the existing work tend to impose strong data generation assumptions, and it requires the practitioner to have a strong causal knowledge and expertise. So unlike existing work, in our approach, we introduce a human-centric paradox workflow that emphasizes the interpretability to tackle the spurious association. And we develop interactive systems and visualization, which we call VISPER, for visualizing spurious association that is designed for non-expert to learn and do causal inference. We want to close the gap between causal theory and the practical use, but we do not want to just have a black box solution. We want to engage people who do not have strong mathematical or theoretical background in causal inference to be able to learn and become more conscientious about the issue, to make sense of the paradoxical association in an intuitive way. So let me show you at a higher level how this works. So suppose users want to know this question: does the training program help people make more money? And there might be a Simpson's paradox. So the systems will incorporate the paradox workflow that include several toolkits, including confounding dashboard, subgroup viewer, reasoning storyboard, and decision diagnosis. So let me walk you through to highlight some of these tools. So confounder dashboard tells a user which factors are likely to be confounders that distort the cause and outcome relationship. So in the system, the users tell the system what is the treatment factors and what is the outcome variables. With this information, the system will automatically identify confounder by computing these confounding scores. And the confounding scores, it actually quantified how the treatment outcome relationship would change with and without controlling a specific covariate. So in this case, the system tells the user ethnicity is the most likely confounder because it has a higher confounding score. We can also see the distribution across treated and untreated groups are really different. All right, in the subgroup viewer, it helps users knowing whether the cause-outcome relationship generalize to other subgroups, and how does different subgroup different from each other. All right, so the users can manually or automatically create these subgroups. With these subgroups, the users can use covariance space to understand whether groups have different characteristics. They can also use this causality space to understand whether there's a differences in this treatment outcome relationship. So here, the user can see the treatment outcome relationship for subgroup is different from the aggregate relationship, which shows in the gray trend. All right, the subgroup viewers have this causality space that allows people to contrast subgroups through this cause-outcome breakdown. So it allows people to look at this trend across treated and untreated groups for both binary treatment and continuous treatment. So basically, you can see this trend across different treatment. All right, the reasoning storyboard. So we saw this is the most interesting part. It helps people to make sense of the paradoxical trends. So if a user wonder why are the trends paradoxical, right? The user can use this reasoning storyboard. So it shows how these subgroups that have different trends. So we leverage a flow metaphor, which visually convey the cause is followed by the outcome or effect. So this help people to intuitively thinking about the cause and effect as a temporal flow, right? So with this, whenever you see an aggregate pattern like this, you see a crossing path, there must be a subgroup that have this heel pattern, right? Which means the cause and outcome relationship is negative. And there must be other subgroup that shows this valid pattern that shows the cause and outcome have a positive relationship. So in summary, it tells you whether there's a paradoxical association and which subgroup involved contributing to the paradox. All right, finally, the decision diagnosis. It helps check whether there's an alternative explanation. So it can help a user to see is the treatment really effective for the group that I'm looking for, and are there any alternative explanation? So the user can have a close look at any subgroup And then the system can calculate this imbalance score automatically. So whenever there's a high imbalance score in any of these factors, that indicates there's a potential for alternative explanation for the treatment outcome relationship. All right, so how do we evaluate this? We evaluate this work in terms of case study. So this involves nearly 500 undergraduate students who are taking a Java programming class. And this tool helps the educator to understand whether providing a Java code example on the online educational system really helpful for improve their programming skills. We also conduct a randomized control user experiment, and the result shows that the participants have higher accuracy when they use our tool Whisper. They show higher accuracy and show more confidence in answering the causal questions, especially for more difficult causal questions. And these are some of the statistical technique behind the tool, including how we measure the compounding bias, how we measure the covariate imbalance, and how we develop this automatic subgroup discovery. So feel free to ask me if you are interested. Okay, so I think that's the final slide of my talk. So I want to share some of my reflection from these two studies. So if you are a computational social scientist like me, who constantly use big data, online data, and digital data to create this measurement process, I would like to invite you to think about this question. What measurement should be created in the first place, and how this measurement can help us understand the progress of diverse and inclusive human society. And does this measurement help critically examine the effectiveness of a policy or technology? And also because the population are always diverse, communities are always heterogeneous, right? And this heterogeneity is associated with the social system that are often interconnected. So how can we measure the couple social system that capture the heterogeneity in human activities? So with that, I want to thank you for your listening and happy to take any questions. Okay, and we have openings for PhD and postdoc. Okay, any questions?
So if in the causal inference tool that you presented, one question is, how do you know what are the relevant factors that determine the independent variable of the users or the subjects? Another thing is, if you adjust or control for a variable, it can still sort of, if it's a collider variable, it can open up a backdoor path leading to correlations that don't really exist. How does the tool handle that?
Good question. So for the first question, so as you can see, the first step is for the user to tell us what is the cause and what's the outcome. So the users tell us what kind of relationship they care the most. So the user tell us what are the outcome variable, what are the treatment variables, so we know what's the dependent variable. So with that, all the covariate can be controlled over and can be measured. The compounding score can be measured. The second question is we say there's a minimal assumption, but you are right. There's still assumption that all the variables all the confounders are measured in the in the variables provided. So with that covariate variables, we measure the imbalance scores. So in the imbalance scores, it tells the user whether it's possible to adjust and make the data balance. We do not guarantee that there's always a balanced outcome here. We just say you have this effect, but the effect may come from this unbalanced data. So that's the message here. And this tool is for helping people to be aware about the paradoxical association. It does not guarantee that you will get a valid causal estimate.
Thank you.
Kind of an obvious question is when you were looking at inequality to internet access, just off the cuff, I can think of a lot of other demographic features like, I don't know, maybe a religious factor or even socioeconomic, obviously. So did you look at that or what? Yeah.
Yeah, we look at various factors. And here for the presentation, I just show the most theoretical interest part. Okay. And also what you say about religious, about other things, because they are almost closely related to those most important factor, which is income, economics, all the things. So controlling for this, it's simultaneously controlling a bunch of socioeconomic, highly correlated factors.
Okay. Yeah, that totally makes sense.
I have maybe a clarifying question. I was a little confused on for the first part of the presentation on the online literacy definition. So the way you're measuring the lower frequency frequent word is by like the set of the distribution is the online distribution, like how people are talking online, and conditioning on that online distribution, you find the frequency word. And so how, I guess a couple, like one is how different is that from our normal vocabulary? Like what is that capturing? And I guess maybe another follow-up is, does literacy gap in the normal definition of offline literacy factor into online literacy, and was that controlled in the study?
The second question first. So this in the traditional literacy, it's just read or write. So traditional is test whether you can have a sentence and be able to read and write. So it's a literate, illiterate. And of course, to be able to get online, you have to become literate first. So we see a correlation with that because that's the only data for the official literacy data we can get across all countries. For the more economical advanced country, you can of course get a more fine-grained literacy using all sorts of very expensive literacy measure. But our goal is to have a global metric. That's why we correlate with that. But you are right. The first the online literacy is conditioned on having a literacy. Okay, so that's a condition. So our goal is to see whether there's a correlation to add as a validation for our metric. Our metric has to at least differentiate this spectrum across country. And the first is the online language. So that's exactly what we use social media like Facebook, because the traditional literacy measure focus only on the like a British national corpus. That's a literacy which is defined by a more like elite group that's using in a more formal way. And what we want is capture the casual use in the online world. That's why we use the online language use in the casual use, which is the Facebook post. And the assumption is if we can use this as a sampling process, is an observation, give an observatory, then we can use this and the distribution to differentiate how different community will rank based on this distribution of casual language use. Does that make sense?
Yeah. And then in terms of the gender gap, like so I'm according to like existing measurement of offline literacy, you probably can measure is that kind of what the dominance versus male dominated country versus including that variable into your analysis is doing the like kind of conditioning on the effect of existing possible literacy gap offline?
Yes, we do control the offline population characteristic. So if we want to explain the variation in the online world, we use the population characteristic as a factor to predict what we see as a variation in the online world.
One of the criticisms I've seen of the Gini coefficient in practice is that there's more inequality if you look at the Gini coefficient globally than in any country individually, right? So that's like kind of what you're saying about maybe misuse if you cut rather like what you choose to focus on. And it strikes me that like creating this global metric where you can compare or maybe sum over different languages means that you can actually start to reason about that same thing but for literacy. Did you find the similar effect where literacy is maybe there's less media literacy equality globally than in any country? Is that translates?
That's very interesting. So that's one thing I skip in this talk. Let me see if, so I do see a very non-trivial link, very complex link here. So this may be associated with what you just asked about the complexity of this multiple inequality. So when we think about inequality, the first thing come to mind is the Gini inequality, which is the economic inequality. But there's also educational inequality, right? So I try to look at how these different inequality factor into the disparity in the online world. And here is the regional disparity. So high means the higher regional disparity, lower means lower regional disparity within a country. And I found here, there's also an interaction that is pronounced in this analysis, right? So I found there's two conditions for this space, right? We found one is there's a relatively high level of income inequality and educational inequality. It's these three corners, right? And that means that the inequality, the online disparity can dominate by any of the high inequality in terms of education or income. And there's a relatively low level of educational in this corner. You can see a low level of educational inequality, but high income inequality, right? So the interpretation is actually very similar to the women civic participation. So when this happens, access to social media will be reserved to the higher socioeconomic group, the group with higher socioeconomic status. So now this also acts as an equalizer to equalize. Then you see a lower disparity within the region. So I think this this kind of a study shows that this inequality actually have a very complex mechanism in interacting with the online world. Okay, so this is also why I'm trying to show that using online world as a measure actually have lots of things that we need to take care of. We need to be very careful for interpretation. Okay.
Thank you so much.
Thank you.